Hey everyone, welcome to the world's first computer vision with Arduino course. Here we are going to learn the basics of how to create real-world computer vision applications using the extremely popular Arduino Microcontroller. We will first start with the basic exercises and then move on to creating exciting projects such as lamp gesture control, PID Face Tracking, angle finder, hand gesture control, color sorter with conveyor belts, and a lot more. The aim of this course is not to create random projects but to understand the fundamentals and give you enough knowledge and experience so you can build your own million-dollar ideas. This course has a clear pathway from basic to advanced with lots of practice examples. This video is part of the course. The complete course can be found on our CVZone platform. The link is in the description below. So without further ado, let's get started. Let's start by understanding the core principles of Arduino using an example. Let's say we have a smart car that is equipped with automated headlights. This car checks the light intensity of the environment and turns on at night and turns off during the day. So what sort of equipment would be required to build such a system? We would need a headlight to output the lights and a light sensor to give us information of the ambient light. Now there has to be something in between that gets the input from the light sensor and outputs the signal to the headlight. This something is the brain of the system. We call it the microcontroller unit. In short, MCU. MCU is like a small computer that can handle small amounts of information really fast. So where does the Arduino come in? Arduino is a company that produces microcontroller boards. They have different versions that cater different scenarios. The most commonly used is the Arduino Uno. They also have more compact versions like Arduino Mini and bigger versions that can handle more sensors like the Arduino Mega. The main difference is the size, capacity, and number of pins between these boards. Uno has 14 digital and 6 analog pins. Mega has 54 digital and 16 analog pins. This means we can connect 20 different sensors and devices to Arduino Uno and 70 to the Arduino Mega. Note that the Arduino does not produce microcontrollers. They produce microcontroller boards that contain microcontrollers. So what's so special about these Arduino boards? Even though when referred to Arduino, the hardware comes to mind, but the speciality of the Arduino is in its software. It makes the process of programming much easier than any other similar device out there. In earlier times, we used to write tons of lines of code just to turn on an LED. But now with Arduino, we can achieve the same result in just 3 simple lines of code. So we can say it is a high-level language that takes care of the coding details for us so that we can focus more on the actual project. So how does the Arduino work? As mentioned, Arduino has its own software through which we can program different sensors and devices, and we can upload it to the Arduino board. We can use a regular USB connection to upload the code using a computer. Once the code is uploaded, it keeps running as long as it keeps getting the power. So let's have a closer look at the most commonly used Arduino, the Arduino Uno. The main component is the MCU that handles all the logic. Then we have the USB connection to upload the program to the board. We also have a power jack that allows external battery to be connected to make it portable. The reset button resets the code without deleting it. Then we have the pins where we attach our components. We have 13 digital pins, 6 analog pins, and we also have power pins with 5 volts and ground. So what do these digital and analog pin mean? Digital signal has only two states, which means it can be on or off, whereas analog signal has a range of states. Let's look at an example of a fan. If we control the fan digitally, we have the option of turning it on and turning it off, where on would mean 1 and off would mean 0. If we control the fan with analog signal, this would mean we have a range of values. Therefore, we can now control the speed of the fan rather than just on and off. For example, the range is from 0 to 255. 0 would mean off, 255 would mean full speed, whereas 127 would mean half the speed. But where did this 255 value come from? Well, this is an 8-bit value, which means we have 256 values. Bit values are used all around us. For example, when you buy a smartphone, you have the option of buying a 64 GB, 128, 256, 512, or even 1 terabyte hard disk phone. So where do all these random values come from? These values are binary values, where 64 is basically 2 to the power of 6, 128 is 2 to the power of 7, 256 is 2 to the power of 8, 512 is 2 to the power of 9, and 1024 is 2 to the power of 10. This means if we were to send a 6-bit signal to our fan, we would have 64 different speeds to control. If it was an 8-bit value, we will have 256 speeds to control. If we include the 0 as well, then our values will range from 0 to 255. Coming back to our automated headlight example, we have an analog input in the form of the light sensor and analog output in the form of a light. Now this time we will use the Arduino controller to run the system. For analog input, Arduino uses a 10-bit value, and for analog output, it uses an 8-bit value. So this means for our light sensor, we get a range of values from 0 to 1023. So 0 would mean dark, and 1023 would mean fully bright. Similarly, based on the light intensity we received from the light sensor, we can output a value to the headlight to turn it on accordingly. For the 8-bit value, we have the range of 0 to 255. So we will have 256 brightness values. Let's have a look at some examples of input and output devices. A distance sensor would be an analog input, a push button would be a digital input, motor would be analog output, whereas LED light would be a digital output. The distance sensor is an analog input because it gives us a value of distance, for example in centimeters, rather than just saying the object is near or far. The push button is a digital input because it has only two states. It can either be pressed or not pressed. The motor is an analog output since it can be controlled with varying speed. The LED light is a digital output because it can be controlled to be either on or off. Note that the motor and LED can be used both as digital outputs as well, since they both can be simply turned on or off. So, to summarize, Arduino is a company that produces microcontrollers, which we can use to control multiple sensors and devices. These devices could be inputs or outputs of the system, and we can have two different types of signals that we can send or receive from these devices. Now, these signals can be digital or analog. Digital signals have two states, whereas analog signal has a range of states. For analog input, the Arduino uses a 10-bit value, which ranges from 0 to 1023, and for analog output, it uses an 8-bit value, which ranges from 0 to 255. In this video, we have just scratched the surface of the Arduino microcontroller, as there is tons of information related to Arduino. To truly understand it, we have to get our hands dirty by experimenting and inventing new projects. The possibilities are endless. We can even build our own custom Arduino boards and use them to create our own projects. In the next video, we will look into the details of how different sensors could be connected to Arduino and how we can use the Arduino IDE to code them. We will see step by step how the connections are made and how we can read and write information from different sensors and display it to our screen. So how can we connect sensors and devices to Arduino? In this video, we will look at the basics of sensor connections and their coding. So we have a lot of sensors and devices that can connect to Arduino, and there is something that is common in most of these devices. So what is that? It's the power pins. Most of them have a positive and negative pin. Let's take an example. This is a temperature sensor that has 3 pins. The first pin is the negative or the ground. It is also referred as G and D sometimes. Then we have the positive pin. Most of the times it is denoted by the voltage level, for example 5 volts, 12 volts, and so on. The last pin is the signal pin, mostly written as S. Now, depending on the sensor or device, it can be input or output. In this example, we are getting values from the temperature sensor, therefore it is an input to the microcontroller. In other examples, such as a buzzer, the signal would be an output. So how do we connect these pins to Arduino? They can be connected by special wires known as jumper wires. These are easy to use and plug in directly to most sensors and microcontrollers. Jumper wires have 2 different types of heads. The one with the pin is known as male, and the one without is known as female. So when purchasing jumper cables, we have the option of purchasing 3 different types. The one we see here is male to female, since one end is with pin and one is without. Then we have male to male and also female to female wires. So which sensor is connected to which pin number of the Arduino board? As we discussed earlier, the signals can be of analog or digital type. In Arduino Uno, we have 14 digital pins and 6 analog. So one could say that all analog devices are connected to the analog pins and all digital devices are connected to the digital pins. Well, that is not correct. Since Arduino does not have true analog output, most of the analog output devices, such as motor and dimming lights, are connected to digital pins where we send a simulated analog signal. We will discuss this more in detail in the upcoming videos. For now, we can say that the analog pins are mostly used for analog input, and for the rest, we use digital pins. So let's see how we can connect an LED light to Arduino. As we know, an LED light has a positive and a negative connection. So we will connect the negative pin to the ground and the positive pin to one of the digital pins, let's say pin number 2. But with LED light, we should use a resistor to limit the current to avoid burning the LED. So we will need to use a breadboard. When using Arduino, many projects require the use of breadboard. So it is a good idea to learn the basics using a breadboard. So a breadboard consists of power pins and component pins. Here we can see the conductive layers inside a breadboard. The connections in the power pins are vertical, whereas the connection in the component pins are horizontal. This means that this point at the top of the breadboard is connected to the bottom of the breadboard. Whereas in the component pins, this pin at the top is not connected to this pin at the bottom. Instead, this point is connected to the horizontal point here in the same line. The space in the center indicates the breaking point. This means that this point here is not connected to this pin here. So how do we connect the components? Let's look at some examples. Most components can be connected in two different ways. If we connect vertically, they can be connected in the same region. When connecting horizontally, they have to be connected between the gap. This means a resistor cannot be connected like this. The power pins are connected in the power pin section. This way, multiple devices can be powered from the same line. So let's see how we can connect an LED circuit to a breadboard. If we look at the circuit diagram, we can simply follow the current flow. So first we will add the LED, then the resistor, and then the battery. We can label each terminal of the components to further understand this. We will connect our power wires. Starting from the positive side of the battery, the current flows towards the first terminal of the resistor. So we can connect this with the wire here. Then the current passes through the second terminal of the resistor and moves toward the positive terminal of the LED. We can add another wire from the second terminal to the positive side of the LED. Then the negative side of the LED goes to the negative side of the battery. So we can add a wire from the negative point to the negative point. So we can see the current flow and how it creates a loop. So now that we know how to connect an LED light, how can we control it with Arduino? We can simply replace the battery with Arduino, where the negative side will go to the ground and the positive side will go to one of the digital pins of Arduino, which we selected earlier as pin number 2. So when we send a high signal to pin number 2, the voltage level at this pin goes to 5 volts, therefore turning on the LED light. And when we send a negative signal to the pin, the voltage level drops to 0 and the LED light turns off. So let's connect this using the breadboard. First we will add our components. Then we will start from the positive side, which is our pin number 2. We will connect it to the resistor, and then from the resistor we will connect to the LED positive side. Then we will complete the loop by connecting the LED negative to the ground of Arduino. So let's program this LED to blink. In Arduino, we have 3 sections of the code. First one is the initializations and declarations. Second is the setup. And third is the loop. The first one we will discuss later. The setup is the section where we define which pin numbers are our sensors and devices connected to, and whether they are input or output. This section of the code runs only once. Now, the loop is where we run the main code. It iterates over and over again. So in the case of our LED, we would write the code of turning on and off in this section. So let's write the code. First, we will add the setup function. Then we will define that our LED is connected to pin number 2, and it is an output device. For that, we can write pin mode 2 and then output. Next, we will close the setup function and write the loop function. Inside this, we will send a high signal, which is 5 volts, to the LED pin number 2. We can write digital write pin 2 as high. Now we will add a delay of 1 second by writing 1000 milliseconds. To make it blink, we have to turn it off as well. So we will write digital write pin 2 as low and add 1 second delay again. Now we will close the bracket. So this code is enough to run the LED blinking example, but it is not the best way to write the code. Let's say we want to change the pin number from 2 to 5. We will have to replace the pin 2 to 5 manually in a lot of places. This is a simple and short code, so it would not take that long. But imagine if we have hundreds of lines of code, that would take a while to find and replace. So what we can do is to add a variable. Now the variable can be added in the first section of the code that we did not discuss before. So a variable is just like a box that has a name and it can store a value inside. So we will write integer myLEDPin is equals to 2. Here the myLEDPin is the variable name and 2 is the value that is stored inside this variable. But what is this int? Well, this is a data type. Integers can have values between -32,000 and 32,000. They cannot have decimal values. Now to upload this code to our Arduino board, we have to first define the type of Arduino board we are using. We are using Arduino Uno, so we will go to Tools, Board, and select Arduino. Then we will select the port number, again from Tools, Port, and then the port number. Note that you might have different port number. All you have to do is to make sure that you select the correct port number. Once you have selected, you will see a tick mark next to it. The last step is to click on Upload. And now your Arduino blinking code is uploaded. If you do not have an LED light, you can use the built-in LED light of Arduino to test. The LED light is connected to pin number 13. So all you have to do is change my LED pin to 13. Let's say we have a motor and a 9-volt battery. If we connect them together, the motor starts to move. Now what happens if I change this 9-volt supply to 5 volts? Well, the speed will decrease. We can say at 9 volts we have high speed and at 5 volts we have low speed. In other words, speed is directly proportional to the voltage. But the question is, what if we wanted to change the speed of the motor without changing the power supply? Because we cannot change the power supply every time we want to change the speed. Well, we could add a resistor. So there will be some voltage used by the resistor and the rest will be dropped at the motor. So the motor will move slower now. So let's say 20% of the energy is used by the resistor and 80% is used by the motor. So the question is, where does this 20% of the energy go? Well, the bad news is that it dissipates as heat. Therefore, this is not a good way of controlling the speed since we are wasting energy. This was the practice up till 1960s, but then somebody came up with a better solution. So let's have a look at that. So let's say we have the same circuit as before, but now instead of the resistor, we add a switch. This switch we can turn on and off. Given that our voltage is 9 volts, if we turn on the switch, the motor receives 9 volts. and if we turn off, the motor receives 0 volts. Now if we rapidly turn the switch on and off, our average voltage will decrease. So if we turn on for 50% of the time and turn off for 50% of the time, then our average voltage will decrease to 4.5 volts. Now, if we turn on for 80% of the time and turn off for 20% of the time, then our average will be higher, which will account for 7.2 volts. Similarly, if we turn on for 30% of the time and turn off for 70% of the time, the voltage will average at 2.7 volts. So this here is our pulse, and by changing its width, we are controlling the speed. Therefore, the term arises pulse width modulation. The percentage of the on time is known as the duty cycle. So in this example, the duty cycle would be 80%. Now, to implement this on a motor using an Arduino or Raspberry Pi is actually fairly simple. With Arduino, there is a native function, analog write, which takes in the pin number of the motor and the speed required ranging from 0 to 255. Here our pin number is 9 and the speed is 127, which is half of 255. Along with this, we can specify the digital write to change the direction of the motor as well. In Raspberry Pi, the GPIO0 package contains the motor module that allows easy use of the PWM. After specifying your motor pins, you can simply type forward or backward with the value ranging from 0 to 1. To control another device such as LED, the Arduino code would be same using analog write. But for the Raspberry Pi, the PWM LED module could be used, where the value of the PWM can be specified by writing LED.value, and this value is basically the percentage. For example, in our case, it is 0.5, which means 50%. Install Arduino, first of all, we are going to go to arduino.cc and we are going to download the software. So here you can see the software tab and you can click on that and that will take you to the downloads, and this is the latest one, Arduino IDE. IDE stands for Integrated Development Environment. So it is like a notepad but with extra features that will allow you to write your code. It will tell you where you made mistakes and it will help you compile the code. So this basically is the Windows installation, Windows 7 and newer. This is the Windows zip file. Now, most cases I would recommend using Windows, the first link. And for the second link, you can use if you are using an office PC or a university PC, which does not allow you to install, then you can use the zip file. But there are some cases where it doesn't work properly. So the best case that installs the drivers as well is the Windows 7 and newer link. So go ahead and click this if you are on Windows. Then if you are on Mac OS, then you can click on this 10.10 or newer. And of course you have Linux versions as well. So what we will do is click on Windows 7 and newer, and if you want to contribute, then go ahead and do that. You can see here it is downloaded 54 million times. Impressive, in fact, yes. And yes, so you could contribute and download, or you can say just download. So that will start the download. It's just 113 MBs, so it should not take a long time. Once it is downloaded, then we will install. So now we are going to install. We will click on it. So we are going to agree with the license agreement, and then we are going to click on next. You can change the location if you want. I'm going to keep it the same. We will hit install and then we will wait for it to extract and install. Okay, so now it is completed. We will close. So here you can see we have the Arduino icon, so we can click on that. So here is an automatic tab generated for us. So here we can write our code. So once you have opened up Arduino, what you can do is you can go to File, Examples, and there will be a lot of examples that you can start off with. But what we will do is we are going to go and install a library that will help us communicate with Python, and therefore we will be able to run a lot of different programs. So we will go to Sketch and include library, and then we will add a zip library. So now you will make sure that the Arduino library that we have for CVZone is downloaded, and that zip file you have stored in a folder. So you will go to that folder and you will click on the cvzone.zip file. Again, all of this you can download from our website, so it should be available in the downloads. So we will click on this and hit open, and this will install the library. So you can see here it says library added to your libraries. Check include library menu. So how can we confirm this? We can click on File, Examples, and we can go down and we can find CVZone. So here you can see these are the examples: Get LED and Send Potentiometer. These are the two examples that come with the installation of this library. So that is the indication that it is installed and we are good to go. So here we have our typical Arduino Uno. There are other Arduino types as well that you can use, but for this course, we are going to use Arduino Uno throughout the course. So you can use another version that is very similar to this. There you go. So only the actual chip that is a little bit different, but the functionality is exactly the same, so you can use either one of these. So the first example that we are going to do is of an LED light. Now there is an LED light connected directly to pin number 13, and that is the one that we are going to use, and it also has a resistor with it. So normally we need a resistor along with the LED light so that it limits the current and it does not burn the LED light. So here pin number 13 is directly connected to an LED, the one that says L over here, and we are going to use that for this example. So let's go ahead and do that. So here in our Arduino code, we have two sections. The first one is void setup. This code will run only once. So this is a comment mentioning that. And then you have a void loop that will run again and again repeatedly. So we don't need these comments. So we are going to ignore those or remove those. And then what we have to do is we have to declare our pins. So which pin numbers are we using? So here we will say pin mode. We are using pin number 13 and we are using it as an output. So we are the ones sending commands to it. So if we are sending commands to a sensor, that is an output. If we are receiving the commands from a sensor, that is an input. So this is basically the idea. So we will write here pin mode, pin number 13 as output. And then to run it, we have, because we are connecting it to a digital pin, which is pin number 13. Digital means we have the option of on and off. So if you have analog means you have a range of values, for example, 0 to 1023, for example. So in this case, we have 0 and 1. So we will write digital write because we are writing, we are sending the value. So we are saying write, and we will say we are sending it to pin number 13 and we are sending the signal of 1. So 1, or you can write it as high as well. But if you write it high, you have to write capital letters. You cannot use H capital and IGH as small. So all of them need to be capital. So then we can simply put a delay of, let's say, 1000 milliseconds. So this is milliseconds. And if you want, for example, 5 seconds, you would write here 5000. If you wanted 10 seconds, you would write here 10. So this will be 10,000. So we are going to use 1, and then we will write here digital writes, and we will write pin number 13 is 0, and then we will write delay 1000 again. So this will blink our LED light that is connected by default. So all we have to do now is to connect our wire to our Arduino and run it. So let's go ahead and do that. So here we are going to connect the wire to Arduino. So you can see we will just plug it in and you can see the sound. And you can see also here we have the LED that is on by default. Maybe there is a code already that is running, but we are going to go ahead and upload this code. So to upload this, we are going to go to Tools. And here in the ports, we are going to select the Arduino Uno. So this is COM6. Some of the Arduinos, they don't really show you that they are Arduino. So sometimes you have to guess as well if you have multiple ports. So we can click on COM6. And the other thing you have to make sure is that the board is Arduino Uno. So here you have to make sure that this is Arduino Uno. There are other types like Nano, Mega, Micro. There's a lot of different types of Arduinos. The one we are using for this course is Arduino. So once that is done, you can see on the bottom right corner, it says Arduino Uno on COM6. And then you can either compile. Compilation is just to verify whether your code is correct or not, if there are any mistakes. Otherwise, you can upload because it will first check whether your code is correct or not, and then it will send the code. So now we will go to the location of our course folder, and there we are going to save this Arduino code. So here we are going to create a new folder, and we are going to call it Arduino Code. And inside here, we are going to write inputs, and then we have outputs. So right now we are working with outputs. So we are going to write here LED basic. So for each input or output, we are going to look at the basic code, and then we are going to look at the code that will allow us to do serial communication with the Python code. So this basic means if at any point you are facing any issues, you should come back and check the basic code. If the basic code is working fine, that means the hardware is fine. There's an issue with the software. So this is a very good idea whenever you are using different sensors. So now it is uploading. It is saying compiling sketch. It is checking if everything is correct. And once it is done checking, it's going to upload. Now it is uploading, and now it's done uploading. So we are going to go to the Arduino board and we will see whether it blinks or not. So there we have our Arduino Uno, and you can see it is blinking. So let me zoom in here, and you can see the orange light is blinking continuously. It is turning on and off for 1 second on and 1 second off. So this is exactly what we wanted to do. Now in the next step, we are going to do the same thing, but through Python code instead of Arduino code. So now we are going to create a new file and the other one on the other side. Now we can simply zoom in and out by pressing the control button and scrolling the mouse. If you want to do that, you can do that to see more clearly. Okay, so what exactly do we do now? Now, if you go to File, Examples, and you go to CVZone, where is CVZone? CVZone, and this is Get LED. So getting is in terms of Arduino. So Arduino is getting the value. That's why we are writing Get LED. Now, this is the basic code of receiving the command from Python and getting it to Arduino. So how does it work? First of all, what we do is we write include the CVZone package. So CVZone. So here we call it library. So we are going to import or include our library. And then there is a class within this library called the serial data. So basically how we are sending the information from Python to Arduino and Arduino to Python is using serial data. So what we will do is we will simply write here serial data, and we are going to create an object. So we will write here serial data. It's pretty much the same thing, but with a S small. So this you can write anything. This is the name of the object. You can pretty much write anything you want, but we are using serial data, so we will use that same. So then you have to write the number of values you want to receive. So number of values you want to receive. So I want to receive, for example, 2 values. But in this case, we only have one LED. So we will write here 1. So we are receiving 1 value. It doesn't matter how long the value is. It can be 4 digits, it can be 2 digits, 3 digits. But here we are just writing the number of values. So we want to receive only 1 value from Python, and then digits per value. So for example, if we were receiving 0 or 1, then it will be only 1 digit. If we were receiving, so this is 0 or 1 is basically 1 digit. If we are receiving the value from 0 to 99, then we have 2 digits. Then if we are receiving from 0 to 999, then it is 3 digits. So I hope you understand this point. I will keep it here in case you want to review that. So in this case, we are only going to receive 1 digit. So either it will be on or off. We don't need to add anything extra. So we will write here 1 digit. and we will put a semicolon. There you go. So I can just copy this for your reference. This is number of values. This is number of values, and this is digits per value received. So this is basically the idea. And once that is done, we are going to create an array. Now this array, basically whatever value is received, it will be stored in this array, because you don't want to create variables one by one and then store. For example, if you had 5 values coming from Python, you have to create 5 variables to store these values. Instead, we will create one array in which we will store all the 5 values. In this case, we only have one value. So even in this case, we have to create an array, because this is how the library works. So what type of values are we getting? We are getting integers. So we are going to write here values receive, and we are going to write here only 1. And then here we have the void setup. In the void setup, we have to define that we have our pin mode, pin number 13 as output. So this is the code for the LED light. And the code that is specific for the library is to initialize our library. So that can be done by writing serial data.begin. So if you have used Arduino before, sometimes we write serial.begin. So this is similar to that. Instead of writing serial.begin, which is for the serial monitor, we are writing serial data.begin. And here inside, you can give in the value of the baud rate. So by default, it is 9600. If you are using a different baud rate, and if you don't know what baud rate is, then you don't need to go into that much detail. But by default, it is 9600. Then in the loop, which will happen again and again, we are going to write the command to receive the value. So simply, we have to write serial data.get, and whatever we get, we want to put it in values received. Values, come on, received. There you go. So it will be stored over here automatically, and then whichever value we want to use, we can use it. So if I wanted value number 1, I will write here values receive at 0. So this will give me the first value. If I wanted the second value, I will write values receive 1. So in this case, we are only asking for one value. So numbers of values received is only 1. So we are going to write that we will only get the 0. But what do we do with this? We send it to the LED light. So we will write here digital writes, and we will write pin number 13 as values received at 0. So earlier we were writing here high or low, 1 or 0. But right now what we will say is get it from the LED, get it from the Python code, and then we will decide whatever the value is, we will send it here. So from Python, we can send our value directly here. So what happens in the Python code is basically it sends a string. So a string will be something like this. It will start with a $, and then there will be 0 or 1. So if we want to send one value, we will write it like this. If we want to send 0 value, we will send it like this, because it is 1 digit. So for example, if we had multiple values, so it will send it like this. So let's say we had 2 values, each with 3 digits. So the first one will be, for example, 001. The second one, let's say, is 265. So these values will come in like this, right? So if I had 3 values with 3 digits, then there will be another digit. It will be, let's say, 13, so 013. So it will come in like this. So this will be our value number 1. So it will be stored in 0. This will be value number 2, and this will be value number 3. So if we want to test it without going to the Python code, we can test that too. So how can we do that? We can simply upload this code. So here we are going to write LED instead of LED basic. Now we are going to write LED, which means it is LED serial. So this will save the code and it will compile. And now what we can do is we can click on the serial monitor. So this is basically how serial commands are sent. So if you wanted to send a serial command, you can send it from here. So right now you can see that the Arduino light is off. There is nothing on the Arduino side. So what I can do is I can write $1 and that should turn on the LED light. So let me bring it a little bit closer. Let's try to focus. So there you go. Now you can see it is focused. So if I write here $0 now, you will see that the LED light turns off. And if I write $1, you see that the LED light turns on. So now we need to send these commands from our Python code. So I'm actually holding it in one hand and I'm typing from the other. That's why it's shaking a lot. So because here it's not very clear. So that's why I'm holding it up. Okay, so now what we will do is we will go to the Python side and then we are going to write the code from there. So here we have opened up Pycharm and we are going to write here Arduino CV. So computer vision Arduino, and we are going to create this project. So this opens up a main file and we can delete that. In fact, we can delete the whole thing. We can right click and where is delete? There we go. So we can delete that and this creates a virtual environment for us. And this is our project and we can create all the files in here. So we will right click and first of all, we'll create a folder, which is called a directory here. So we are going to call it outputs. So we are working with outputs. Later on, we will work with inputs as well. So we can write that to directory and inputs. So here in the outputs, we are going to create a new file, a Python file, and we are going to call it LED. So this is basically our LED code. And what we will do is we will first of all install our CVZone library, which includes all of the functions. So we will go to settings and here we will go to projects and we will click on Python interpreter and here we are going to add. So here we will write here CVZone and we are going to hit install package. Now keep note of the version. So if at any point, if you are not able to work or if you're not able to work the code, if it's not running properly, then you should come back to the exact same version. So do try the latest version, no problem with that. But if it doesn't work, you can always click on specify version and then you can choose which version you want to run. So here we are using 1.5.1. So make sure you use this. And this is automatically going to install NumPy and OpenCV for us, which is the back end of our computer vision functions. So everything which is related to computer vision, it is done by the OpenCV library. We have the CVZone package, which is kind of a wrapper for it, which allows it to have extra functionality, and that is pretty much it. So now to run the LED light, what we have to do is you have to send a serial command. So to send the serial command, we need to import the serial module. So we will simply write here from CVZone dot serial module import serial object. And then we are also going to delay. So to delay, we need time. So we will write from time import sleep. Import sleep. So if you remember in Arduino, we wrote a delay 1000. Here it will be sleep and we can give it a delay. Okay, So now here is the interesting part. What you will do is you will create the Arduino object. So you'll write here Arduino. This is just the name. You can call it anything you want. And then this is the object. So serial object that we imported. So we will write it here and we will not give it any arguments. So no input parameters. So why is that? By default, it will detect the Arduino if there is something, if there is any Arduino connected to the computer. If your Arduino does not get connected, then you can specify the COM port. So here, if you go to tools, you go to ports, here you can see it says COM6. So if it doesn't work by default, you can put quotations and you can write here COM6. So if I do that, it will connect to Arduino. So we can right click and we can run LED. Okay, so there is an error, import serial, and that is a good point because we forgot to add a module. So while we are working with the CVZone package, it does not install the serial library for Python by default. So we have to install it. So we will write here PySerial. There you go. So we will write here PySerial and we will hit install. Again, keep note of the version, it's 3.5. So we will hit OK and then we will run it again. There you go. So it says serial device connected. So it means it is working properly. But as I mentioned before, you don't need to write anything here. It will automatically detect any Arduino that is connected and it will run that. So if I run it again, here it says Arduino Uno is detected on COM6 and it is already connected. So this is the first part, and then we can write a loop. So we will write here while true. So this is like writing the infinite loop in Arduino. So we will write here while true and we will write Arduino dot send data. And remember, we are always sending a list or an array. So in Arduino, we are receiving an array. In Python, we are sending an array or a list. So here we are going to write brackets, and in that brackets, we are going to send the value. So let's say 1. If we were sending more than one value, we can write here, let's say 2, and then 6, and 5, and whatever values we are sending, we can send it like this. But here we are only sending one value, so we will simply write that. Then we can give it a delay, so we will write sleep for 1 second, and then Arduino dot send data, and then we are going to write 0. So we want to send 1 and then we want to send 0, and then we will write sleep for 1 second. So this is basically the idea. Actually, let's do something. We will turn it on for 2 seconds, or let's say 3 seconds, and we will turn it off for 1 second, so that it is a little bit different than our plain Arduino example. So we know that our Python code is working. It's not just the previous code running on Arduino. Okay. So as you can see on the Arduino, nothing is happening right now. So if I run this code, it says Arduino Uno connected. And now you can see the LED light, it turns on for 3 seconds and it turns off. Turns on and then turns off. Okay, let me zoom in a little bit so you can see. There you go. So here you can see it turns on for 3 seconds. And then it turns off, turns on, turns off. There you go. So this is how you can send the command from Python to Arduino. Now we do not have to change any code in Arduino side. All we have to do is we have to change code in the Python side to work as we wish. So this is very convenient. So now that we have the LED working, what we can do is we can add a little bit of graphics. So we did not use the computer vision library so far. So what we can do is we can give it some sort of visual effect, some graphics, so that we can see it working in real time. So here we are going to write import CV2, which is our computer vision library. CV stands for computer vision. And then what we can do is we can import some images, and then we can display whether the LED is on or off. So what we are going to do is we are going to create a new folder here, and we are going to call it resources. Resources. And inside this resources, we are going to add our images. So again, all of this can be found on our website. You can download it from there, and you go to resources and you can so all of this folder you can download directly. Here I will bring in one image one by one so that it is easy to know what are we dealing with. So now what we are going to do, we are going to use this LED off. This is LED on. Since it is an orange LED, we are using the orange color. And then we also have an image that has this orange light on here and then orange light off here. So we can use either one of these as we wish. So how can we do that? Let's go ahead and find out. So here we are going to first import our images. So we will write here image LED on is equals to cv2.imread. So we are reading the value, reading the image. We are reading it from the resources folder. Resources. And within the resources folder, we have, should we use this or that? Let's use this one first, LED on dot jpg, and we will copy the same thing and we will paste it here, and this time we'll write off and we will write here off. So now what we can do is we can display this image. So how can we display that? We can write here cv2.imshow, and we are going to write the name of the window, let's say image, and we will write image LED on, because here we are sending the command of on. So we will write here on, and then we will give it a delay. Now this delay, we cannot use sleep. There is a specific delay when we want to use the, oh, I did a mistake. I should have used another file, LED graphics. So it will be easier for you to know what is happening. Let me copy that here, and we can push this back to the original code. Here we will remove import cv2 LED, and there you go. So this is what this was our old code, and that we will keep it like this, and then we will go to the LED graphics where we left off. So we are writing here, and we were saying that we cannot use the sleep because there is a delay method for the computer vision library, and it is called cv2.waitKey. And here we can add delay like we did in Arduino. So here we will write milliseconds. So here we will write 3000 milliseconds, which is equals to 3 seconds. And then we will copy this part and we will remove the sleep, and we are going to write here image LED off, and we will delay for 1000 milliseconds. So we can remove the sleep from the time library, and yeah, that should be good. So let's go ahead and run that, and let's see if we get any image. So we are facing an error. So there is an issue with the device. Did we turn it on somewhere? No, it seems fine. Let's run that again. Okay, so yeah, there is an issue with cv2imshow. -215 assertion failed empty. See, the reason I'm still showing all these error, all these mistakes, is so that you can understand how this works. I could very easily edit all of this, but I'm not doing that, so that you learn live. So learning live is very valuable. You can see what sort of mistakes other people do, so you can learn from them as well. Okay, so this seems to be an issue, and I will tell you there's a very small issue here. The issue is that the file that we are using is in this folder outputs. And if I want to use the resources folder, what I need to do is I need to go back to the previous folder, which I can do by writing .. Again, .. .. So if I do this, it will go to the main folder, and then it will search for resources, and then it will search for LED. Otherwise, it will not be able to find. So let's run that again. And there you go. So 3 seconds it will be on, and 1 second it will be off. Actually, let's make it even. Let's make it 1 second on, 1 second off. It will be easier to see what is going on. So on, off, on, off. Let me zoom in the Arduino as well. So there you go. It's on, off at the same time. So we could do the same thing with the other images. So we can copy this part and we can comment it by pressing Ctrl and slash, and then we can paste it here. And instead of the LED on, instead of the LED on, we are going to write here pin 13 on. And here we will write pin 13 off. There you go. So let's run that, and there you go. So where is it? There you go. So on, off, on, off. See, the result is very subtle, so it is a little bit hard to see, but I hope you get the idea. So it turns on and off based on this LED example. So you can bring in any kind of image that you want, and you can have on and off images as you wish, and based on that you can write your own code. So now we have Arduino Uno attached to a board. This is a plate which is made of metal. Now if you have a wooden plate, that is recommended. So later on we are going to use wooden plates as well. So, and we also have a breadboard attached to it, and the only thing that we have done is that we have connected the positive and negative, which is 5 volts and the ground, to our breadboard. So the red wire here is the positive and the blue wire here is the negative. And sometimes with breadboards, what happens is, not sure if that is clear. Let me remove one light. There you go. I think that is more clear. So what happens sometimes is that you will see that there is a dash or there is a gap in between this line. So this red line and this blue line. So if there is a gap between these lines, it means that the breadboard is not internally connected. So you can attach a power supply here and a separate power supply here. So if you want to use the same power supply all the way, then you have to attach these small cables. So we are going to use these. We have a box of them. So these are specifically breadboard wires. So they come in this box, all different sizes. So we can use these to attach to our breadboard. So what we are going to do, we are going to attach a potentiometer. A potentiometer is basically a variable resistor. So resistor can be used to limit the current, and this is basically a variable resistor, which means that it can vary its resistance. Let me try to focus that. There you go. So how does it change the resistance? How does it vary it? By rotating. So if you go to your car and you change the volume, there is a potentiometer inside. So when you rotate it, it increases and decreases the resistance, which increases and decreases the volume. So this is how it works in your car. And this is the same concept that we are going to use. And we are going to check the resistance within our Arduino board, and we are going to receive the values in our Python code so that we can plot it. We can plot a graph. We can use these values in different projects. So how can we use this? We cannot directly attach it to the Arduino. So what we have to do is we have to attach it to the breadboard, and from the breadboard we can attach the power and the negative, the ground, and then the signal pin we will attach to one of the analog pins. So this will give us an analog reading, which means that instead of on and off, it will give us a range. So whenever we rotate the potentiometer, it will give us a different value. And this value will range from 0 to 1023 because it is a 10-bit value. So the resolution is 0 to 1023. So where exactly is the positive and negative? So the positive and negative, it's not exactly defined. So you can use this as positive or you can use this as positive. It's pretty much the same thing. And the middle one here, this is the one that is a signal. So this will send us the signal. The positive and negative on the side you can flip as well, and it will not be a big difference. So here, how are we going to attach this? We are going to simply place it here, let's say over here, and now we are going to attach our positive and negative cables. So we can put it at the end, and we can attach it to the positive and negative, because this line is positive and negative, so we don't need to go to our Arduino board to connect it. We can simply connect it here, and the signal pin, we will bring it up from here and we will connect it to A0 over here. So let's go ahead and do that. So here we have different size of cables. Let me bring in a little more light. There you go. So we have a lot of different sizes here. So let me open that up. There you go. And what we will do is I'm going to find a small one because there's not a lot of distance here. So we will grab maybe this red one. So the red one is attached and the yellow one is a little bit bigger, I believe. And we are going to attach it to the negative. So the negative will be 1, 2, 3, 4 here. There you go. So let me show you here. So let's remove the light a little bit, and hopefully you can see here. So this here is the positive cable. It is connected to the red part, and this here is the yellow one. It is the negative cable. So all we have to do now is to place it here with the negative and positive. There you go. There you go. So the circuit diagram of this is also available on the website. So if you're not able to understand it from here, you can always check the circuit diagram. And the last pin that we have to connect is basically the signal one. So what we will do is we will take, let's say, an orange color. So orange is normally signal, red is basically positive, and black is usually ground. So we are going to place it in between here. And what I like to do is I don't like to place it directly like this, because then it is visible like this. It is in the air. So I don't like to do this. Instead, what I like to do is I like to push it down. Therefore, I have added these gaps. So these are these spacers, you can see. So you can push through the wire from down so that it is easy to manage and it will look much cleaner than before. So here you can see I have done the same for the positive and negative. So I'm going to push it down here, and hopefully it will come from the other side. There you go. And then I can simply plug it in here. So pin number A0. And now I can push the remaining part inside so it is not that visible. There you go. So it is much neater this way. So there we have it. So now that our connection is done, we will go ahead and write the code in Arduino. So the first thing we will do is use the basic code to see if everything is working fine, and then later on we are going to add our serial communication part that will send the commands to our CVZone package in our Python code. So here what we will do is we will declare that our pin mode number A0 is basically input. Now you don't necessarily have to do this because by default it is an input, but just in case if you want to, you can write it here. Then we are going to write serial.begin 9600. This is for the serial monitor, and we are not going to use this when we are doing serial communication with Python. We will only use this when we are just testing the device. So here we are testing the potentiometer, so we are going to use it. So here we are going to write, for example, integer, let's say potentiometer value is equals to analog. So now we are going to read the value, and the value that will be read will be analog, which means it will be a range. It will not be just 0 or 1. It will be from 0 to 1023 because it is 10 bits. What does 10 bit mean? 10 bit means 2 to the power of 10, which is equals to 1024 values. So this is the resolution. So you can have 1024 different values. And because we use from 0 to, we start from 0, therefore it is 0 to 1023. If we started from 1, then it will be 1 to 1024. But because in programming we start from 0, so we use 0 to 1023. So this is how this value comes about. Then analog read, what we are going to read A0, and then we are simply going to print it. So we will write serial.print, and we will write print always in a new line. LN means new line. So we will write here, what do we want to print? We want to print the potentiometer value. So if I run this now, before we run it, we actually have to connect it. So we are going to connect it to the Arduino board. There you go. And then we are going to click on Tools, Port, and we will select our Arduino. So you might see different Arduinos each time we are doing a different device because we are using different Arduinos for different projects. So then we are going to click on Upload, and again we are going to save it in our course folder. Here in the inputs we are going to write here potentiometer basic. Okay, so now it's done uploading, and we can click on the serial monitor, and this should give us the value. So right now it is giving us 0. So let me go ahead and move it, and we'll see if the value changes. So here I will rotate it, and there you go. So now you can see the value is changing quite dramatically, and there you go. It stopped moving, stopped moving, stopped. So there you go. So it goes from 0 to 1023. So now we need to read this value in our Python code. So we can make use of it, we can plot it, we can draw it, we can use it in different projects, and so on. We can also click on auto format, so it arranges everything for us. So now we are going to create a new file, and then we will put this on one side, and we have the other on the other side. And what we will do is we will use the code to send this value to our Python code. So here we will write file, we'll go to file examples, and in the examples we'll go to CVZone and send potentiometer. So these are the two basic examples that we have, get the LED and send the potentiometer. So let's say that this is our code. So what exactly are we doing? So first of all, we are going to include CVZone. So this is the library that we are using. So include CVZone.h. This is the header file. Then we are going to write serial data like we did before in our LED example. Serial data, And this time we are going to write integer send values, and we will put the value of 2. Now, whatever the value you are sending, if you are sending one value, it's fine. If you're sending two values, you have to write minimum of 2 here. So don't put less than 2, don't put 1 here. Sometimes it creates some issues. So it is highly recommended that you don't put the value of less than 2 here. Even if you are using only 1, it is fine. Just use the value of minimum 2 here. So minimum value of 2, even when sending 1. Okay, so that is the basic idea. And then again, the idea here is that we are going to send an array. We don't just send one value one by one. We send an array of values, and that's how we communicate with the Python code. So here we are going to write serial data dot begin. So last time we wrote it like this, and as I mentioned before, you can write the baud rate if you want. So you can write it like this. So then we are going to write in our potentiometer value. So here we will write, we only have one potentiometer, so we are going to write integer potentiometer value is equals to analog read, and we are going to read the value of A0. So we are not going to read the second potentiometer, we don't have it at this point. And then we are going to write send vals at 0 is equals to potentiometer value. Now here we are just storing the value in that array. Once we store all the values, right now we have just one value, so we have stored everything. If we had multiple values, like over here we had 2 values, then we will store that also before sending it. So once everything is stored in that array, then we can write here serial data dot send, and we will simply say send all the values. That's it. So that's how simple it is. And remember, don't use, like we used it here, serial begin. Don't use this. You cannot use this because by default it is using it internally. So now we can save it. So file, save as, or save. We can put this in inputs, and this will be potentiometer. So that is saved, and now we can upload the code. So if we open up our serial monitor, you will see that the values are being sent. And if we rotate, you can see the values are sending. So this is basically the idea. And now what we can do is we can go to our Python code and we can receive the values over there. So here we are in our Pycharm project, and the first thing we will do is we will create a new file in the inputs, and we are going to call it potentiometer, and we are going to receive the values from the potentiometer. So like before, we are going to write from CVZone.serial module import serial object, and we will call this Arduino is equals to serial object, and we will not define anything because by default it will find the Arduino. So we will write here while true, and then we are going to write my data is equals to Arduino dot get data. So whatever data is there, just get it, and then print my data at value 0, because we know that we are receiving 2 values. The second one we will ignore. The first one is the one that we want. So we are going to write it like this, and let's run this and see what happens. So there you go. So now we are getting it, and let's go ahead and I will move the potentiometer, and there you go. So it is updating in real time. When I rotate it, you can see now it's the maximum value. and then I move it back, and there you go, it is reduced. So this is how you can send the value of the potentiometer to your Python code, and you can print it out like this. So now we are going to add some graphics to this potentiometer. So we will right click and create a new Python file, and we will write here Potentiometer Graphics, and we are going to copy this code and we are going to paste it here. Now to add the graphics, we first need to import CV2. So we are going to write here import CV2, and then we also need import numpy as np. So I will tell you why we need numpy. So once that is done, we are going to read in our image. So we will write here that our image is equals to cv2 dot im read, and we are going to read again. If you remember last time, we have to go back first. So we will put 2 dots and we will put a backslash, and then we will go into the resources folder, and then we will go into a new file. Did we copy it yet or not? Resources, no. So I'm going to bring it here. Again, this will already be available in the resources folder if you have downloaded it from the website. But this is the file we are going to use, potentiometer. So potentiometer.jpg. And then we can simply show it. So we will write here cv2.imshow. We will call it image and img, and then cv2.waitKey, which is there to delay. So that should be good. So let's go ahead and run it to see if it is running properly. And there you go. So this is the potentiometer control dial, and here you can see this is the value that is coming here. So what we need to do is, what we can do is, we can put a bar here, a circular bar that rotates and tells us how much value do we have. So here it will be 0, and then all the way till here it will be 1023. So that will be visually appealing, and in the middle we can write our text of what exactly are we getting in terms of the raw value coming from here. So how can we do this? First of all, we cannot just draw a circle. If we draw a circle, we do not have the option to draw half a circle or 90-degree circle, or we cannot draw a portion of it. But what we can do is we can draw an ellipse. In OpenCV, it allows us to draw basically a portion of it rather than the complete part. So for example, we will write here cv2.ellipse, and we will draw it on our image, and then we have to give in the center position. Now these values I have already taken from the image, so you can copy it exactly like this. Otherwise, you can, if you create your own image, feel free to play around with these values so that you find the correct center. So this is the center for our image that we have right now. And then we have the axis. So this will be 131 and 131. And then we have the angle. So the angle by default should be 0. And then this is the starting point of the arc. So that will be, let's say, 0. And then the ending point, so let's say that is 90. For now, later on we can change it. And then we have the color. So let's put the color 255, 180, and 0. And then we have the thickness. Let's put it as 10. So do we need anything else? I think it should be fine. So let's go ahead and run it. And there we go. So this is your arc that is being drawn right now. So this is what we get. So the first thing is that 0 is at this point. So we need to start from minus 90. So let's rectify that. So instead of 0, we will start from minus 90. There you go. So it is starting from minus 90 and it is going till 90. There you go. And then if you want to know what this is the value of how much stretch do you want in the X and the Y direction. So if it is not the same value, it will not be a circle. So let's say if I put here 200, you will see the effect. There you go. So now it is stretched in the vertical direction, and if I put it 200 over here, then it will stretch in the horizontal direction. There you go. It is stretched in the horizontal. So we don't want that. We want it to be exactly like that, 131, 131. And this is of course the center point. If I move this, it might not draw. Let's see. Yeah, it moves, it just shifts, offsets. So this is the basic idea. Now, what exactly do we need to change? We need to change the last value, the final value. So what we can do is we can send in the direct value that we have. But here the issue is that this will intake, let's say, from -90 to 270, right? So this is the intake for this point. If we put 270, it will complete the circle. But our value that is coming from the sensor is from 0 to 1023. So we need to change this range into this range. How can we do that? Let me put it like this as a comment so you can reference it later. And so how can we do that? We can do it by a little bit of maths, but we can also do it with the NumPy library. It actually allows us to change the value. So we can write here numpy dot interp, and we need to give in our first value, the one that we are getting, the one that we want to change. So that will be my data at 0, but this is a string value. This is not an integer. So we need to convert it into an integer. This is just text. So we will convert it, and then we will give in the first range. The range we are getting it is 0 to 1023, and the range that we want it in is -90 to 270. This is the range that we want it in. And now the output value will be the correct value. So we can simply write that, let's say our value is equals to this. So that's the idea. And now I can take this and I can put it over here, value. So if I run this now, did it change? It's giving 500 something. Okay, let's move it. There you go. So it is moving and it looks really smooth. There you go. Now the thickness can be more. Let's say 16. Yeah, maybe if we want to cover it all, I think maybe 25. What is the value? Oh, there's an error. Yes, this error, I will tell you why this happens. Sometimes the data is not coming properly, so it gives us an error. Still, we need to add a little bit more, maybe 27. Okay, there you go. I think that's fine. So this looks nice. And what can we do next? Oh, yeah, we need to fix this as well. When it goes to 0, it draws in the center. So we don't want to do that. So what we can do is we can say that only draw. Should we do it before or after? So we can write here value is equals to my data, or we can do it after as well, actually. No, we have to do it before. My bad. So here we have to write value is equals to my data at 0, and we will write that if value is not equals to 0, then we are going to draw. We will push this in, and we can put value over here instead of my data 0. So if we have the value of 0 now, it should not draw at all. Okay, again we are getting the same error. Now this error you can remove by simply writing try and then accept. Some people might consider this a lazy way, but it is fine for this case. It works. We need to push it in till here. That is good, and we need to remove this. There you go. So now it should not give us this error. If it's unable to get the first value or something is wrong, then it will ignore it and it will run again. So this happens only once or twice in the beginning, and later on it should work without any issues. So writing it this way is not a big deal. Okay, let's run it. Okay, so it's still not working. Why is that? Oh, this is outside. Wait, why is this outside the loop? Should be by mistake. I think I pushed it outside, and there you go. So, but why is it still showing? If value is not equals to 0, then only it should draw. Let's check the value. Why is it giving print value? Let's check that. It is 0. Then why is it showing this? Because this here right now is a string. So we need to change it to string, or we can change this to integer. But we can do it like that. Okay, yeah. So here it is not showing anything. And then if we rotate, it should show the values. There you go. So that is basically the idea. We can remove this part here. And what else? Do we need to do anything else? Yeah, we can put the value actually. So we can write here cv2.putText, and we can put the image, and then we will put the value. Now the value, we can directly put it like this, but then sometimes it will be 2 digits, sometimes it will be 3, so the position will keep changing. So what we can do is we can always give it 4 digits. So if it is, let's say 10, then it will write 0010. If it is 100, it will write 0100. So it will fill a 0 in the start if it is not 4 digits and whatever digits are required. So we can write value.zfill, and we will tell it to always have 4 digits. And then we are going to write here the position. So again, I have already checked what the position should be. cv2.font Hershey plain, and then we will write 3, and the color we are going to put white. We are going to put white here, 255 and 255, and then we are going to put 3 as the scale. Not the scale, the thickness. Okay, so this is the scale, this is the thickness. So let's run that, and there you go. So 368. Let's try it. There you go. It moves 0, 0, 0. So what I was mentioning before, let me show you again. If we don't do zfill, then you will see the values, they shift. So now it's 4 values, it looks good, but then here 2 value, 1 value, it just looks bad. It's not centered, so it doesn't look that good. So that's why we are using the zfill. So it always remains in the center and it looks good, whether it's 2 digits, 1 digit, or 10 digits. Not 10, 4 digits. So that's basically the idea. So now we are going to create our face detection project. So in this project, whenever we detect a face, we will have our LED turn on. So we will send the signal from the Python script to our Arduino code to turn on an LED light. So we will go ahead and right click to our project folder, and we will create, actually let's create a new folder first, directory, and we will call it project 1, and we will call it face detection So here we are going to right click and we will create a new file and we will call it face detection basics. So to detect faces is actually fairly simple. We are going to use the MediaPipe package that is provided by Google, and we have a wrapper for that, which is our CVZone package, which makes it easier for us to detect these faces. So that's what we are going to use. So here we are going to import CV2, and then we are going to write cap is equals to CV2 dot video capture. So we are going to turn on our webcam, and I have multiple cameras. I will be using camera number 1. So if you have just one camera, then you can use ID number 0. Then we will write here while true, and we are going to write success, and our image is equals to cap.read. So when we call this function cap.read, it will output us an image and whether it has detected, whether it has grabbed a frame or not. So this is the basic idea. And once we grab the frame, we are going to write cv2.imshow, and then we will write image and image. So this is the name of the window image, and this is the image itself that we want to display. And the last thing we have to do is we have to add a delay, otherwise it will not work properly. So we write cv2.wait key and we put 1 millisecond as the delay. So this should open up our webcam. So let's right click and run. And there you go. So you can see me, and this is our webcam, and you can see that it is working fine. There is no lag, no delay. And what we are going to do is we are going to find my face, and if the face is there, then we will turn on the LED. If it's not there, maybe I will block or I will do something like this, and we will see what happens. We want it to be closed when we want to turn off the light when the face is not detected. So this is the basic idea. So now we need to find the face. So to do that, what we will do is we will import the face detection module. So we will write here from CVZone.face detection module, not face mesh, face detection module import face detector. So using this face detector, we are going to find our faces, and we will write here detector is equals to face detector. So that is our face detector. Now to run this, we need the MediaPipe package. So we will make sure that our MediaPipe package is installed. So we are going to write, we are going to go to File, Settings, and then we will go to the Python interpreter. And here you can see the MediaPipe package is not installed. So what we will do is we will click on Add, and here we will write MediaPipe. So this is the MediaPipe package, and we are using version 0.8.7.3. Now you can use the latest version, whatever you have. If it doesn't work, you can go back to this version, a specific version. So you can use it from here. You can click on specify version, and then you can select which version you want to use. So we are going to install this package. Now, if you are doing this for the very first time, it might take a while. So be patient. Once it's done, we will continue with the code. So now that the package is installed, we will close this and click OK. And now we can move ahead to our coding. So we already initialized our face detector. Now what we need to do is we need to use this face detector to find the faces. So we will say detector. So this is the class, and this is the object created from this class. So we will write here detector dot find faces, and then we will write image. So we want to find the faces within this image that we have grabbed from our webcam image or webcam frame. And what will it return? It will return back the image with the bounding box drawn, and it will also give us the information of the bounding boxes. So if there are more than one face, there are multiple faces, then it will be stored over here. So let's run that and see if it works. There you go. So if I move around, you can see the face is detected. If I tilt as well, you will see it still works. And this is very good because earlier methods like Haar cascades, they don't really work when you tilt the face, and there's a limit to that. So only the frontal faces are detected. But here you can see when we move on the side as well, it is detected and it is tracking as well. So this is the basic idea of face detection. Now, if you want to play around with the parameters of this face detector, then you can do it here. So there is minimum confidence. Detection confidence means how much confidence you need to detect as a face. So by default, it is 0.5. 1 will be 100%. So if it's 100% sure it's a face, then it will detect it as a face. So we usually keep it at 0.5. If you want it to be a little bit tough, then you can write 0.8, for example, to make it a little bit harder. But if you are unable to find the faces, you can reduce the value, let's say 0.3. But then you might get false detection as well. It might find the chair as the face as well. So there is a trade-off. You have to work around with that. So this is the basic idea of how you can find faces. Now we are going to add our LED code to it so that whenever we detect the face, the LED turns on. For the Arduino code, we are going to use the LED code that we wrote in the output chapter. So here it is very simple. We are including our CVZone package. We are initializing our serial data communication. We are saying that we are going to receive one value and each value will have one digit. So one value with one digit. So it can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the idea. And then we have to initialize serial data.begin. Here the baud rate will be 9600 by default. And then we have the pin mode 13 as output because this is the one that we are using. We are not connecting an external LED. We are using the internal LED connected at pin number 13, which already has a resistor attached to it. So that's why we are using that. Then we are saying get the data from our serial communication, get it from the Python script, and whatever value you get, send it to digital write pin number 13. So if it's on, make it on. If it's off, turn it off. So that's the basic idea. Now we are going to upload this. So we will go to tools, port, and COM9, and we are going to hit upload. So the code is now uploaded. We can go to the serial monitor, and here we can write $1, and you can see the light turns on. And if we write $0, you can see the light turns off. So this is the basic idea. Now we can go to our Python script, and based on that, we are going to turn it on and off. So here in Pycharm, we are going to go to our project folder. We will right click and we will create a new file, and we will call it face detection LED. So we will copy the face detection basics code and we are going to paste it. And then we are going to import our serial module so that we can initialize our Arduino code. So we can write here from CVZone dot serial module, we are going to import serial object. This is the idea. And then we are going to write that our Arduino is equals to serial object. So it will find automatically which COM port it is, and it will connect it to Arduino. Then once the face is detected, we need to do something. We need to turn on our LED. So here, first of all, we need to check whether something is detected or not. So we will write if bounding boxes. This means that if there is something inside the bounding box, then we are going to write Arduino dot send data, and we will send the data always in a list. So we will create a list and then we will send the value of 1. And else, if nothing is detected in the bounding box, it's empty, then we are going to write Arduino dot send data, and again in the list we are going to send the value of 0. So if the face is detected, it will send 1 and it will turn on the LED. If the face is not detected, then it will send a 0 and the LED will turn off. So let's go ahead and run this and see if it works. So there you go. Now the face is detected and you can see the LED is turned on. Now if I cover the image, the camera, now the LED is off and now it turns off. Turns on. Off and on. Off, off, and on. So it's very subtle. So that's why what we are going to do is we are going to attach another LED light, the one that you are looking at on the side. This red LED is basically RGB, and based on that we will turn on red or green light. So that will be a better indication of this light. So let's go ahead and do that. So the first thing we will do is to connect our LED light, which is RGB. Now you can see that here it has three negative pins for ground and then 1 voltage pin. So the negative ones are RGB pins. So if we give it 0, then it will turn on. If we give it 1, which is high, then it will turn off. So it is a little bit opposite to what we are used to. So it is RGB, and whenever we want the red color to turn on, we will turn it off at our pin connection. So it's a little bit weird, but we can get used to it. Now to connect this, we are simply going to use our jumper cables. We are going to connect them directly here. There you go. And then these pins we are going to connect directly to our Arduino board. So we will first connect the voltage pin, which is the green pin, the last pin here. So we will connect it to 5 volts. And the rest of the 3 pins, they are going to go to our signal pins. So we can pick any of these signal pins. We will connect them to pin number 8, 9, and 10. So these are the pins that we are using. So this is basically our connection. Let me focus that here. You can see this is our connection, and now all we have to do is we have to plug it in and run it. Now for the RGB code, it is actually fairly simple. It might seem complicated, but it is quite simple. All we have to do is we have to initialize our pin numbers. So we can write here integer red is equals to is 8, then integer blue is 9, and then integer green is 10. So it's not RGB, it's RBG. So the way they have connected, the way the pins are laid out. So we will define these numbers and then we will put all of them as outputs. So we will write here pin mode, our red LED is basically output, and then we will copy this part and we will say blue and green as well, they are outputs. So this is the idea, and now all we have to do is we have to send them the signal. So it is up to us what we want to send them. Now let's say I want to turn on all of them and make it white. So if you have all 3 colors, it will become white. So we can write here digital writes, and we will send the red as 0, and we will copy that, paste it and paste it, and here we are going to write blue and then green. So if all of them are 0, it should turn on, and what we will do is we will add a delay so that we can see the difference, and then we will turn all of them on. So we'll turn them off. So this is on and this is off. 0 means on and 1 means off. So let me write here turn on, and this one is turn off. So let's go ahead and run this. So we will right click here and create a new folder. We are going to call it projects, and inside that we are going to write here project 1, and inside that we are going to save it as RGB LED basic. So this is the basic code. We are not adding the serial part yet. So let's go ahead and see if it works. So right now it just turns on, it never turns on. Oh, I forgot to add a delay, that's why. So you need to add a delay at the bottom as well. And there you go. So now it's turning on and turning off. Now let's try different colors. So if I wanted, I could add, let's say, the red color. So to add the red color, these two, blue should be off, green should be off, and red should be on. So now it will go on, 0, and then red. There you go. So there you go. Now you have red, white, off, red, white, off. So that's the basic idea. And what we can do is, if we wanted to add more color, we can, for example, write here blue. So we will type blue, and for blue we are going to put this as 1 and put this as 0. So that will turn on. Let's just auto format this to fix it, and let's run that. And now you will see that you have the blue color as well. So red, blue, white. So it's a little bit tough to see on the camera, but in real life it's very easy to see, and you can see what is happening. And what we can do is we can also add a diffuser on top of this. So something like this. So now the color difference is very visible, and you can tell which color it is. So red, blue, white, and nothing. So let's do one thing. We are going to add the green as well. So to test 3 colors. So we will write here green, and we will put this as 1, and we'll put this as 0. So let's run this and see what happens. White, nothing, red, blue, and green. There you go. So now we are able to see all the colors, and it looks quite good. So now we are going to write the code so that we can receive the values from our Python code, and we can turn on different colors of our LED light. So first we are going to include our CVZone package. So we will write CVZone.h, and then we are going to initialize our objects, which will be serial data, and we will call it serial data. Let's put the D capital data, and then we are going to receive 3 values, R, G, and B, and each one of them will be a single digit. So either it will be on or off. So because we are not going to use all the colors, we are just using green, blue, and red. Okay, so then we are going to write that our values received will be an array of 3 values. We will write it like this. And then we are going to write here that our serial data dot begin, and at the bottom we are going to receive the values. So we will write here serial data dot get, and we are going to write vals received. So we are going to receive all the values, and then we need to send them. Now, how do we do that? We will copy our code for the LED RGB light. We will paste it here. Then for the setup, we will copy and paste it here. And then we are going to copy one of these. And instead of 0, 0, 0, we are going to write values received at 0. then value received at 1, then value received at 2. So should we do RGB or BGR? So RGB, let's do RGB. So the first value will be going here, 0, and then the second value, which is green, will be going here, and then the third value will be going here. So it will be R, G, and B. So that's basically our idea. And yeah, that's pretty much it. So we can run this, and we are going to save it. We are going to save this as RGB LED. So now we can open up the serial monitor to test it, and we can write $. And if we write 111, it should turn off. There we go. And if we write $011, it should turn red. There we go. It turns red. Then then we are going to write $, and let's say 0, let's say 101, and that will turn it to green. So second one is green. Then we will write 110, that will turn it to blue. So that is basically the idea. Now let's go ahead, and we are going to run it from our Python code. So here in our Pycharm project, we are going to go to our project, we will right click, and we will create a new file, and we are going to call it face detection RGB. Now this is not very different from our face detection LED, so we are going to copy that code and paste it here. Now the biggest difference here is that once the face is detected, we are not sending one value, instead we will sending 3 values. So here it is R, G, and B. So I can write here, it will be R, G, and B. So we wanted to turn on the R, the red. No, this is when it is detected, so we want it to be green. So we will write here 1, 0, and 1. So this will turn on. So let's write here 0 is on, 1 is off. So this is basically the idea. Let's write it like that. Okay. So if we want to turn it, what other color we have? We wanted to turn it to red when it's not there. Then we will put it as 0, and we will put this as 1. So now it will turn red and green based on whether the face is detected or not. So let's go ahead and try it out. So now you can see my face is detected, so it is green color. And if I put my hand in front, you will see it turns white. Why is it turning white? It should be red. So it is, did I run? Okay, I ran the wrong code. We need to run face detection RGB. I ran the previous one. Okay, so now it is green. And if I put my hand, it turns red if it's not detecting. Then again, you can see it becomes green when it finds a face. And let me put something. Let's put the MacBook. If I put the MacBook in front, it becomes red. Now the face is detected. I can move around. It will still detect. If I put the MacBook again, it turns red. So this is basically the idea of how you can create a simple project using OpenCV and Arduino. And you can communicate this data between each other very easily using the CVZone package. And you can detect face using the MediaPipe package, and we have a wrapper for that within the CVZone package. So it is literally 20 lines of code, and we are able to create this project.